Welcome back to the period number 5 of a matrix. The question is, if f of x equals to x square minus 2x minus 3, then find f of a, where a is a matrix of order 2 by 2 having the elements 1, 2, 2, 1. So solution, f of x is given to us x square minus 2x minus 3. So f of a will become a square minus 2a minus 3. a square minus 2a इस कांस्टेंट के साथ आइडेंटिटी मैट्रिक्स i का मल्टीप्लाई करेंगे कांस्टेंट के साथ एंड दिस आइडेंटिटी मैट्रिक्स विल बी ऑफ द सेम ऑर्डर i2 2 by 2. So now a is given 1 2 2 1. A square means we have to multiply this matrix 2 times, that is not to square the elements but we have to find out the product of the matrix A. 1 2 2 1 minus 2 1 2 2 1 and minus 3 identity matrix 1 0 0 1 of order 2 by 2. Now we have to multiply these two matrix. 1 into 1 1, 2 into 2 4, 1 plus 4 5, 1 into 2 2, 2 into 1 2, 2 plus 2 4, 2 into 1 2, 2 into 1 2, 2 plus 2 4, 2 into 2 4, 1 into 1 1, 4 plus 1 5, minus this becomes 2 4 4 2 minus 3 0 0 3. Now their corresponding elements, if we subtract 5 minus 2 3, 3 minus 3 0, 4 minus 4 0 minus 0 0, 4 minus 4 0 minus 0 0, 5 minus 2 3 3 minus 3 0, that is a null matrix. Finished. Now comes to next topic, transpose of a matrix, which can be denoted by a dash or a to the power small t or a to the power capital T. If any matrix of any order, if A is any matrix of any order, that is, let A is equals to 1 2 3 4 5 6, it is of order 3 by 2, and for this matrix, if we are going to interchange their rows and columns, if the rows are changed to columns and columns are changed to the rows, then it is known as the transpose of this matrix. Let us see here, A dash will be equals to, the first column will be interchanged to the first row and the second column will be interchanged to the second row. The first column is interchanged to the first row and the second column is interchanged to the second row, and the order will also reverse it 2 by 3. So its order is 3 by 2. The transpose of a matrix order will become 2 by 3. So this is known as the transpose of a matrix, and the similar operations we can do it, addition, subtraction or the multiplication, and it can be denoted as a dash or a to the power t or a to the power capital T. Now comes the properties of a transpose of a matrix. If A and B are the matrix of the any orders, but they are must be here for addition in case they are same orders. So A plus B, the whole transpose, first we have to add up the matrix and then we have to take the transpose, and here we have to individually first transpose both the matrix and then their corresponding elements must be added up. So A plus B transpose equals to A transpose plus B transpose. In the same way, A minus B, the whole transpose equals to A transpose minus B transpose. In case of product of the matrices transpose will be equals to B transpose into A transpose. If a matrix is transposed twice, transpose of a matrix, and again we take the transpose of the same matrix, it will become equals to A, and K into A, the whole transpose, when scalar quantity is multiplied, then it will become only a scalar quantity and the transpose of a matrix. First comes to symmetric matrix. Symmetric matrix is a square matrix, and that matrix is known as a symmetric matrix if its transpose becomes equals to A. If A dash is equals to A, then the given square matrix will be known as symmetric matrix. Second, skew symmetric matrix. It is also a square matrix, and for skew symmetric matrix the condition is that A dash must be equals to minus of A. Means when we take the transpose of a matrix, it should be a minus of A, then that square matrix will become a skew symmetric matrix. Next comes idempotent matrix. It is also a square matrix. For any square matrix, it will become a idempotent matrix if A square is equals to A. If we multiply that matrix, we get the value for A square, A into A, and it becomes again equals to A, then that square matrix is known as a idempotent matrix. Now comes for nilpotent matrix. Nilpotent matrix is also the square matrix. For any square matrix, the condition is that A to the power m equals to 0, where m is here 1, 2, 3, 4 is known as index of a matrix. It means that if we are calculating A square, we get all the elements 0, then it will be an nilpotent matrix of index 2. Otherwise, again, next we have to proceed for A cube. If in case of A cube we are getting all the elements 0 as a null matrix, then it will be a nilpotent matrix of index 3. It means पहले हमको A स्क्वायर निकालना है. अगर A स्क्वायर के सभी एलिमेंट्स 0 हो जाते हैं तो वो nilpotent मैट्रिक्स होगा इंडेक्स 2 का. नहीं तो फर्दर हमें A क्यूब निकालना पड़ेगा. A क्यूब में अगर हमारा सभी एलिमेंट्स 0 हो जाते हैं, नल मैट्रिक्स बन जाता है, तो वो होगा हमारा nilpotent मैट्रिक्स ऑफ इंडेक्स 3. इसी तरह involuntary matrix, it is also a square matrix, and the condition is that the A square must be equals to the identity matrix. If we are calculating A square and if we are getting the identity matrix of the same order, then that given matrix is known as the involuntary matrix. For orthogonal matrix, it is also a square matrix. The condition is that A into A dash, that is transpose, or A dash into A must be equals to an identity matrix. I am putting one example here for the orthogonal matrix. A equals to 1 by 3, minus 1, 2, 2, 2 minus 1, 2, 2, 2 minus 1, 1 by 3. Now we are going to take the transpose of this matrix. This fraction coefficient 1 by 3, don't take it as minus 1 by 3, 2 by 3, 2 by 3, 2 by 3. Just write 1 by 3 as such and reverse the elements, interchange the rows and columns. Minus 1, 2, 2, 2, minus 1, 2, 2, 2, minus 1. Now we calculate the product A dash is equals to 1 by 3 A का हो गया, A dash भी 1 by 3 का हो गया. प्रोडक्ट निकाल रहे हैं, इसका मतलब 1 by 3 to 1 by 3 क्या हो गया, 1 by 9. अब हम इसका रो और कॉलम्स का प्रोडक्ट्स निकालते हैं तो हमें क्या मिलेगा, यहाँ पे 9 0 0 0 9 0 0 0 9. You can calculate and see, and now we can divide with the 9 to each element. We will get 1 0 0 0 0 1 0 0 0 1, which is equals to I3 identity matrix. So therefore A is orthogonal matrix. A is orthogonal matrix. Now comes the next question. If A and B are symmetric matrix, then prove that AB minus BA is a skew symmetric matrix. Solution: since A and B are symmetric matrix and condition is A dash will become to A as it is a symmetric matrix and B dash will be equals to B. It is our equation number 1. So now we have to show that AB minus BA is a skew symmetric matrix. Now AB minus BA का transpose, as I told, AB transpose minus BA transpose equals to B dash A dash minus A dash B dash. Since AB the whole transpose equals to B dash A dash, so now B dash is equals to B and A dash is equals to A dash is equals to A, B dash is equals to B from equation 1. If we take minus sign common, AB minus BA, it will become. So here we can see that AB minus BA का transpose equals to minus of AB minus BA. If we take it as this complete AB minus BA as stored in the D variable, it will become D dash is equals to minus of D. Therefore, AB minus BA is a skew symmetric matrix. Is a skew symmetric matrix.